Okay, let's see. Yep, it's working now. Okay, cool. Alright, give me 1 second and we'll start talking about this. Okay, so we finally got the issue figured out. I don't know why my microphone decided to not work for the first 5 minutes of this stream, but here we are. It's exciting to be here talking about this finally. So I'm going to open up my file explorer and let's take a look at what we have going on with the Phoenix 1 stuff. It may take a moment because I'm just looking at the actual files that I have saved in my computer. But let's see. So I guess first off, I should probably talk about the development. So let's see if this wants to work. Just trying to get my screen over onto it. Does not look like it wants to work. There we go. Okay, cool. So this is the development of the Phoenix 1 vehicle. So I released a video a few months ago at the end of October talking about, I wasn't talking about it. It just showed all the development footage and stuff from Phoenix 1 and showing the first flight. That video did surprisingly well, got 2,000 views, which was very unexpected. But this is what the development of Phoenix 1 looked like. So here are different versions of the TVC. Don't know if opening them will make it actually pop up on the screen, which it won't. Because why would it do that? Let's see. Nope, that doesn't want to work. Yeah, good times trying to get the laptop to work. Okay, it's not that big of a deal. But what you can see here are various photos of the thrust vector control mount while it was in development. This specific model is called TVC-1, or TVC-1, doesn't really matter. But this is the original version here. Can't get it to upscale because it doesn't want to work. But this is what the original looked like. And then this was the development, well, post-development actually, making the final ones. So these are all the parts. It's split up into 3 parts, primarily. You have the outer gimbal, which is this blue part here, the inner gimbal, the gray part, and then you have the motor mount, which is this other blue part. It's a bit harder to tell with this on the gray. Let's try one more time trying to get the actual photo up. Yeah, it's not going to work. It was worth a shot. But, so this is the development phase. So there was actually a prototype Phoenix 1 version. Let's see if I can upscale this a little more so it's easier to see. Okay, I'm not going to be able to make it go larger. Maybe, I don't know. It's not that big of a deal. But this is a prototype body tube that I made for it. And this is the original launch pad. I had to scrap the original version. Or this isn't the original. My apologies. This is the real one. This is the one that's actually being used before it was painted. And this is the nose cone, the original blip computer. Or sorry, this is the first TVC-1. This is the very first prototype. Here's the pyrotechnic mount. This has all the power charges that deploy the parachute. Whenever I've flown Phoenix 1, it only uses one of these at any given moment. Here, give me one moment. But, so this is the charge mount, as I call it. This, it basically is a coupler that holds together the top and bottom parts of the airframe, and also holds the power charges, like I mentioned. Now, let's look at the first flight test. If you've seen the official video on the YouTube channel, I released that at the end of October. Let's see if we have good footage on here. Excuse me. So this is the uplook video, looking at the first flight. If I can get it to work yet again. Let's see. There it is. Okay, we actually got it to work for once. Cool. So this is the camera that looking up at the rocket. I just realized I have this way zoomed in on here. Give me 1 second. How do I unzoom this? Sorry that this isn't the most quality live stream, but folks on X were asking me to talk about this, so I figured this would be the easiest way to talk about the 4 flights so far. But as you can see here, if you look up over here, the rocket is facing sideways. It's horizontal at this point. And, you know, that's what we'd refer to as suboptimal. So, you can see rocket's tumbling out of control there. Now, the issue with the first flight was the thrust vector control system got disabled about a half second into flight due to a premature flight state transition. Now, what that means is the way that Phoenix 1 is set up in its software, it's split up into 4 different phases. So you have your pad idle mode, which is where it's just sitting on the launch pad. So right here, this is your pad idle. So it's just sitting on the launch pad, nothing's really happening. Then the second state is the ascent state. So that's whenever it's actively controlling itself using TVC. And that is initiated whenever the IMU on the vehicle, in case you don't know what that is, that's the inertial measurement unit. The IMU has a gyroscope and an accelerometer built into it. It also has a few other things, but they're not necessarily important to what I'm talking about. But the way that it knows whenever it's starting to fly is that it'll detect that it's lifting off, so it'll detect a higher amount of force on the Z at 5 feet and then 10 feet or whatever. It's actually a metric, but I'll just keep it in feet to keep it simple. So it's saying it's 5 feet, 10 feet, but then there's this bit of data that comes back that is noisy, and it says, now I'm at 7 feet. So now it thinks that it's descending, so it automatically transitions it into the descent state. And what happens there is the thrust vector control is turned off, and this is what happens when your TVC is disabled. Not exactly optimal, but then I resolved that issue using a trick in the software to basically say it has to be saying it's descending for this amount of time before it'll actually transition over. So let's see. So this is the second flight test of Phoenix 1. And this was at dawn, which ended up making for some very cool camera angles. But we got about a second or 2 seconds of stable flight, and then it does a little bit of a tumble. Now this was a major improvement from Flight 1. This flight achieved a maximum altitude of 70 feet, or about 25 meters, I want to say. Can't remember the exact number off the top of my head. But it successfully ascended for about 2.5 seconds. And it turns out the issue with this flight is the thrust vector control mount was gimbaling the wrong way on the x-axis. So what you'll see here, if I'm going to slow it down a little bit so it's easier to see it, is oh, I need to mute the audio. That sounds funky. I don't think you can hear it on the stream. But what you can see here is, okay, so it starts to tilt this way. It starts to tilt to the right. And what's supposed to happen is the thrust vector control system is supposed to gimbal to the left, because that'll create a torque on the vehicle. And essentially what will happen is, now just imagine my mouse being some sort of vector. I don't know how exactly to describe it. But it'll cause it to spin, so that way this nose will start to come more this way. It'll come more straight. Now the issue is, the thrust vector control mount is actually making it go this way, so it's causing it to spin more into the error. And the result of that is this rapid flip that you see here. It's mostly stable, and it's very stable on the y-axis, and then it flips on the x-axis. The x-axis, I probably should have explained this. This is the x-axis of the vehicle, and then the axis going, so if I were to draw a line on the ground, this way is the x-axis, so left and right, and then forward and backward is the y-axis, and then the z-axis is up and down. And not exactly optimal when you have the TVC mount gimbaling in the wrong direction. And this is the result of that. Overall, the vehicle ended up being fine, and I was able to prepare it for another flight a few weeks later. So I got that flight. So this is flight test 3 of the Phoenix 1 launch vehicle. Now, this was by far the most successful flight, and this was a successful thrust vectoring flight of the vehicle. Now you can see here, I don't know why the quality isn't very good, but it takes quite the turn after liftoff. It takes a bit of a turn, but it manages to correct itself, and the reason the data tells me that, but the way you can confirm it yourself just by watching this, is, here, I'll slow it down. Nope, I don't want that. What you'll notice is the vehicle never tumbles out of control until after the motor burns out. So it's still stable, it's not flipping out of control. This vehicle should flip out of control if it's not controlled. And right there, there's motor burnout, and there's where the flip happened. The more obvious place to look, but if you want to confirm it yourself, that's the confirmation of it. Now this flight was extremely successful. Here, I'll pull up some of the other camera shots of it. Here's an onboard camera. I don't know if this one will work. So this is looking down at the vehicle. And you can see it starts to spin a little bit right before motor burnout, but overall extremely successful. Someone's probably gonna get dizzy because of that. What I like about looking at this camera too is you can see it clearing the launch tower. I've always thought that was neat. Here's the other onboard camera. This is more of an engineering camera, just for me to look at, monitoring the x-axis servo. Still get some cool camera shots. Overall, though, extremely successful. Yeah, I'll pull up one more camera angle of it. So this is a static camera that I set up. This one got some cool camera angles. The picture that I have as the thumbnail for this live stream, as well as whenever I was trying to figure out the microphone issue, is also from this camera. And here's something interesting you can note from this view, actually. This is what I was talking about earlier, is the flight state transitions. I have the computer programmed so that way this light right here will change whenever it lifts off or goes into the descent state. But right now it's green, indicating that it's pad idle, and what you'll see here is it goes to a white light. Something interesting to consider. So, Flight 3, full success. The reason it tilts at liftoff is due to winds, but it controls itself, as seen here in this video. So Flight 3 is a success. Huge success. First successful TVC flight for KSLS. You have flight test 4. Give me one moment to pull up that video. And Flight 4, not entirely, not great. So here, I'll just let it play. That's Flight 4. Some would call that suboptimal. This was anything but a success, especially following what happened with Flight 3. So it looks good for about a half second there, and then that's not good. If your rocket's there, that's not good. And it stuck itself into the ground. So here, I'm going to pull up one of the other camera angles. And there's some interesting stuff you can note from this. Not from that one. Here it is. Here, give me one moment. I'm going to black this out for just 1 second. Give me 2 seconds. I'm not trying to show my face or anything on here. There we go. Okay, so this is right before this is at liftoff rather. But something you can see here, this is the, if we go back to the other video, what you'll notice is that at the moment of liftoff, I don't know if I can zoom in on here, but this flame is gimbaled back already. And basically the issue with this flight, I'm going to black the screen out for just one more second here, is, let's figure out which camera it is. Whoops, I accidentally just completely X'd out of it. That's not good. 1 second. Okay, there it is. I think it's this camera. Okay, it is. Now, something... I have to unhide my screen. Whoops. Something you'll notice here is watch this servo motor. I had to fix the pad. You can see how it jump starts there, basically. And then what you'll notice is that over this time, it's winding up. And essentially what happened is, I'm going to switch to one more screen. So this is the actual data from the rocket. I don't share this much, but I'm going to for this, to talk about it. Let me find Excel on here. Okay. No, that's not it. There it is. So this is the data for Flight 4. I'm not going to show all of this because this is mostly confidential stuff. Yeah. Okay, there we go. Okay, let me scroll back up to the top real quick. So the two categories we're going to look at here are the X and Y orientations. So that's these two. So I'm going to zoom the rest of the way in on these two. There we go. Now what you're going to notice about these are, look at the values. They're never at 0. And that's a major issue. Now this is over time. And you can see what we're working with here. This is extremely bad. So the rocket is thinking that it's almost upside down. And this is the Y attitude. So it's thinking it's pointing almost completely 90 degrees backward. Which is horrendously bad, to say the least. You want your rocket to be pointed the right way. So it's thinking, I'm pointed all the way backwards, and I need to make sure that I'm not pointed all the way backwards. So basically, what it does is it tells the servos here. Now this is the servo data. It's saying this is where I need to be at. Now this is at a limit, so that way it doesn't overextend to any point. So this is your X and Y. What we can see here is that these are at their limit or almost at their limit. And what you'll see here as we get closer to the end is after the vehicle actually lifts off, these X and Y orientations are completely off. So the rocket thinks it's pointed in one way whenever it's pointing a completely other direction. And I think I have a solution for this issue. I'm not going to share it quite yet. I don't know if I will. I plan to take a lot of this stuff public at some point. Make most of this info public. But not yet. Because this is still a one-time result at the moment. We're still trying to learn how to make the rocket do what it did during Flight 3. So how do we repeat that result? And here, I'll pull up the Flight 3 data, actually. That'll have something interesting to look at. Let me find it on my screen. There we go. So this is the data for Flight 3. So this is your orientation here. These are your orientation boxes. Rows, whatever you want to call them. But what you can see here is these numbers are a lot better. It only thinks it's 5 degrees off or 3 degrees off or whatever. So essentially what I'm going to have to do is figure out a way to get these numbers to be 0 before liftoff. And I think it should be in this frame. No, it's not quite here. Let's find it. 1 second. These numbers. But at the moment of liftoff, it's saying it's at 8 degrees on the x-axis and 5 degrees on the y-axis. And you can see that it's thrust vectoring, trying to fix these, and this number is increased due to it coming into the wind. But you'll see it's actually increased. Numbers get a little funky, but overall, Flight 3, extremely successful. So what we're targeting to do with Flight 5 is eliminate the issues we've seen with the orientation estimates, and also simplify the launch procedure. There's one more issue. We had an issue with the launch pad arms opening today, which was strange because we have not ran into that issue before. But we'll look at it. It was, if I remember correctly, it was about 12 degrees Celsius according to my flight computer, or about 48 degrees at the launch site today. So I'm not sure if that had a part to do with the performance of the battery. The launch pad uses a car battery essentially to power it. It's funny fact. It's the same battery that was used to launch Phoenix 1, or not Phoenix 1, Serpent 1. Which, if you're unfamiliar with that was the first rocket I built for the KS Launch Systems project, basically to prove that I could build a rocket. That rocket used 3 engines and launched to an altitude of, I want to say, 2,000 feet, or about 450 meters. It's somewhere in that ballpark, but that was a long time ago. That was 2022, if I remember correctly. But yeah, so this is where we're at with the Phoenix 1 development right now. We've had 1 successful flight of 4. Today wasn't great, but we'll figure it out. I'm hoping to launch again later this week. These issues don't seem like they should be too hard to solve. But going up more straight with no wind, the first one to attempt landing. I need to update the website quite a bit on Phoenix 1 stuff. But the ultimate goal with KS Launch Systems is pinpoint accuracy landings, essentially, while going higher and faster. So basically, bigger rockets, more realistic to what you'd see in the actual aerospace industry, landing accurately. So at a designated launch pad or landing pad that I set up, that's the ultimate goal. And all these flights are contributing with helping to get to that point. So with outlining that there, I'm going to end the video, or not the video, the live stream here. And I just realized you did not see anything that I was talking about. I was showing the launch footage for flight. Let's see. There it is. Maybe. No. Now none of these want to work. The joys of trying to use File Explorer to do a live stream about rockets. Is that one it? Maybe. No, that one's not it. What about this one? No, that's not it either. Ay. Yeah, what do you expect? It's a KS Launch Systems live stream. Nothing ever goes right. Let's see, will this work now? No, it's not going to work. There it is. Okay, it actually does work. But what I was saying, this is the goal. Just flying more straight. This is our goal. And I think we'll be able to do it with Flight 5. We have all the data we need. So it's going to be exciting. So follow along on X for updates on it. That's where I post most frequently. You can also follow along on the KSLS website. That's kslaunchsystems.space. That's linked in the description too. But we'll figure it out. This is a development program. These things are difficult. So we'll get it to work soon, hopefully. So with that, all in this here. So thank you for watching. If you did, I appreciate it. And hopefully we'll have a reliable TVC rocket sometime in the near future. And whenever that time comes, it'll be extremely exciting. And I think we'll be able to land a rocket within the next 3 years. So that statement's probably gonna bite me in the butt, But I'm going to leave this here. So thank you for watching, and